Slope of a tangent line. So in geometry, the tangent line, or simply the tangent, which we also know is a trig ratio, right? But tangent to a curve at a given point, Lazar, come on. You catch up later. It's okay. You go in the hall. At a given point is the straight line that just touches the curve at that point. So what I want you to do is sketch the tangent line to each of the curves. So you want to draw a straight line that just touches the line at that one point, right? Doesn't cut through, because then that would be 2 points. Doesn't miss it, so you can't sort of, hey, there's tangent, okay? It's got to touch. Although my odds of drawing one with the board the way it is are pretty slim. So, is there? Oh. What? Now it's on. Fine. So there's a tangent line, right? So it touches that. Wow, that's kind of off. It's pitched, but you get the idea, right? This tangent line is going to look like this, right? Just a straight line, kind of horizontal line. And this one. Yeah, and they're lines, so they got arrows on them. They go on forever. Okay. So far, so good. What's not good? If a secant line, so secant line is actually a line that's going to cut the curve. It'll be drawn through 2 points, P and Q, on a curve. And then if we move the point Q along the curve towards P, the secant line will rotate. Okay? So you imagine, here, I've got the secant line through P1 and Q1. Okay, and then here, and then here, and then here. You see how that's rotating? And it will rotate towards a limiting position which occurs when Q meets P, right? So as we drag Q in closer and closer and closer to P, they're going to meet. The line at this limiting position is the tangent line. Therefore, the slope of the tangent is the limit of the slopes of the secants as Q approaches P. Right? So as Q approaches P, the limit of the slope of those secants will be the slope of the tangent line. That was one of the problems of calculus. There were 2 problems in calculus. One was finding the area under a curve, which is called integral calculus. That was actually developed before this. And the second problem was finding the slope of a tangent line to a curve, and that's called differential calculus, and that's what we're doing now. Use the diagram below to write a formula for the slope of the secant QP. So what's the slope of this line? What's the slope formula?
Mx plus 2, y equals mx.
Well, let's go a little more general. Yeah, so like x2, y2 minus y1 over x2 minus x1. We call that what? What over what? Rise over run, right? So it's the change in the y value. So if we're going to do this, we're going to say, well, okay, you've got this y value. So y2 is f of x. So the slope of the secant will be y2, which is f of x, minus y1, which is f of a, over x2, which is x, minus x1, which is a. So it's f of x minus f of a over x minus a. Maybe I'm supposed to write it like this. Use that as the division bar. Doesn't matter. So, good. Where do I have to push down here? It's off there, but it's writing it. Never understand this stuff. The slope of the tangent at x equals a can be determined using either of the following 2 formulas. So, slope of the tangent at x equals a is the limit as x approaches a. So let's go back. I can do by pushing there. So the limit as x approaches a, right? As we move q towards p, then x is going to approach a. Push here. which is the limit as x approaches a of, and we had that, right? So it's f of x minus f of a over x minus a. So that's formula 1. Also refers to a type of car racing. Then there's formula 2, also a type of car racing, where we let x equal a plus h. So in that case, let's see if I push this, I'll move back. Yes. So we say that, instead this will be a plus h, and then this will be f of a plus h. Right? So now we're saying, hey, there's some difference h between these guys, right? I'm going to add on h to a. That'll take me from here to here. And then what we want to do is, well, we want to get closer, so we want to figure out where we push there. Okay, so f of x minus f of a. So x is equal to a plus h. So f of a plus h minus f of a over a plus h, right? And all we're doing is replacing the x with an a plus h, minus a. And it'll be the limit as, well, x approaches a, but x is now a plus h. So it's the limit as a plus h approaches a. Okay, so all we've done, we just took formula 1, and we're just sticking in, instead of x, everywhere we see x, we're writing a plus h, right? To just say, hey, here was a, and there's some distance h. You're moving horizontally, right? You're adding to the x value. And what we want to do, well, let's subtract a from both of these, so that'll be the limit as h approaches 0, right? In other words, as we move the one point to the other point of, okay, well, f of a plus h minus f of a over h, right? Because you got a plus h minus a, which is a minus a, and h. So just over h. And we've seen that kind of limit, right? Limit as the denominator approaches 0. And we've done a lot of those. That was the whole basis of doing limits, right? Was to get to this point, where we can now develop the formula for the slope of a tangent, right? Solve the problem of, and then who did it first? Was it Newton or Leibniz? Yeah.
Not the guy that his calculus was like metaphysical. And I think Newton was just like without that shit.
Well, actually, I found a video. There's a couple of like 12-minute videos on Newton versus Leibniz. They actually show Newton's notebooks. I mean, it's kind of cool to look at, this guy who may have been the first, although it was probably Leibniz. But then there's another just audio on who did it first as well. But you're looking back at a notebook where it's like May 20th, 1654, right? And here's my stuff. Like, wow, that was a while back. And we go the wrong way. Okay, nothing else there. So, equation of a tangent. Oh, wait, so before we do that, let's do this. Oh, wait, push. No, that's not it. So here, this is a GeoGebra file, whatever, that does this idea, right? So this is the secant line. I can show you the tangent line if I push on show slope. Maybe. Really? Yeah, I could probably do it on here. Hey! Go to self, go to computer. So that's the tangent line, right? Just like we sketched, and there's the secant line. And what we want to do is say, well, what happens? So as we move this closer, right, we've got h. So let's show the vertical length. Vertical length. All right, so you notice we have this distance here is, so this point here is the point f, oh, sorry, it's the point x plus h, comma, f of x plus h. And this point here is the point x, f of x. So this distance here is y2 minus y1, or f of x plus h minus f of x. That's your rise. And your run is x plus h minus x, which is just h. Okay? So just erase. And what we want is the limit as h approaches 0, right? So right now h is 3.2. I'm doing this on here. So if I go up here and grab the h slider, so if I do that, you can see, well, okay, that's just moving further away. So as we move closer and closer, the slope of the secant line approaches the slope of the tangent line until h is 0. And then here we are, and I can show you the slopes. Okay, now notice the slope of the secant line is undefined. Why? Because it's over 0, right? We made h 0, so we can, let me just, oops, it's this slider here. So as I move this, you can see the slope of the tangent line is 0.33, and what's happening as h approaches 0, the slope of the secant line is approaching the slope of the tangent from either way. All right, so there's a nice little GeoGebra demonstration, and I want to switch cleanly back. Aha. So, to determine the equation of a line, what do you need to know? In order to get the equation of a line, you must have the slope, right? You need to have the slope of the line. This goes back to a previous math course, which was what, 10 or 20, I can't remember, right? But in 10 or 20, you know that to get the equation of a line, you must have, I think it's 20, let's call it 20-1. You need to know the slope of the line, right? So if you have 2 points, you can calculate the slope. If they give you the slope, you've got the slope. And what else do you need? You need the slope, and you need a
Intercept.
Yeah, what's a more general?
Look at 0.
Well, yeah, that's a particular example of the thing that you need. You just need a point. You just need any point. So a point on the line. So if it's an intercept, that's a point on the line. They're easy ones to work with, but you can use any point, right? So if you know 2 points on the line, you take 2 points, you work out the slope, you plug in the slope with one of the points, you get the equation of the line. If you know an intercept, that's a point on the line, etc. Equations of lines can be expressed in general form, which is ax plus by plus c is equal to 0. A, b, and c must be integers, and a has to be positive. Okay, so no fractions. You can't have like 2/3 x, etc. Right? It's got to be 2x or plus by plus c. These guys are all integers, and a is greater than 0. Or slope in y-intercept form, which is y equals mx plus b. Right? M is the slope, b is the intercept, x and y are just variables, and m and b can be fractions, whatever. And let's push here. Determine the equation of each of the following lines in the form ax plus by plus c equals 0, where a, b, and c are integers and a is greater than 0. Okay, so for f of x equals 3x squared minus 2x plus 1, use formula 1 to determine the equation of the tangent line at a particular point. Right? In this case, at the point x equals -1. Okay, so if I want to determine the equation of the line, I must have the slope. Okay, how are we going to get the slope? Well, slope is equal to the limit. Now, formula 1, so it's x approaches, in this case, a, so our value, right, as x approaches -1 of f of x. Well, that's right, hang on, let's do this. I like formulas first. So it's the limit as x approaches a of f of x minus f of a over x minus a, right? You flip the page back and you'll be looking at formula 1. Okay, which is equal to the limit. Okay, now we have a value for a, it's -1, right? We want the x value to be -1. Right, everybody okay with the x plus 1? It's like, where did plus 1 come from? So x minus a, so x minus -1, which is x plus 1. All right, well, what's f of x? Well, it's defined here, right? So the limit. Okay, so f of x is 3x squared minus, wherever I see f of x, I can legitimately write 3x squared minus 2x plus 1. And then we've got f of 1. Now I'm going to bracket that, right? Just because I just want to say, you know what, I want to keep that there. Just that's an expression. Minus f of 1, I'm going to bracket this. So it's 3 times negative 1 squared minus 2 times negative 1 plus 1 over x plus 1. Okay, this part's good. No, we're still copying. I'm just going to slide it up a bit. Take anything important off. So we're just doing some math now, right? Go, remove brackets. So that's 3x squared minus 2x plus 1. Okay, what's this work out to? So what do we got? 3 plus 2 is 5 plus 1. That's 6, right? Stare at it long enough, the truth will emerge. Or you'll say, I messed up. That's not 6. So I'm thinking it's minus 6. Too far on that. Okay, remember, I make mistakes all the time, so your job is to catch them before we get like 4 pages into a thing and say, wasn't 2 plus 2 4? All right, what do we got? 3x squared minus 2x minus 5 over x plus 1. So here's the thing. That has to factor, right? And one of the factors has to be x plus 1. It's just, you know, if life is to work out as we planned it, which, by the way, it never does. So I'm doing fake factoring, right? Which is just to say, well, if that's 3x squared, then that's going to be a 3x, and that's going to be a minus 5. And if life is good, then this will be 3x squared plus 3x minus 5x, which is minus 2x minus 5. Ah, see, life is good. Then what do we do? We cross these guys off. Then what do we do? So now you can put the negative 1 in for the x, right? So 3 times negative 1 minus 5, which is ultimately negative 8. All right, so we've done all that work, and what did we just find? We found the slope of the tangent line at or when x is equal to negative 1, right? Because the slope of the tangent line, you can see it flinging down. So the slope, that's the slope. You can see that the tangent line, the slope of the tangent line for that, it will change depending on where you're at on the curve, right? So I could go in, you know, to decimal, we could graph that curve and just say, hey, when you're at negative 1, hey, then your slope is 8. But what's the equation of that actual line, right? So actually, you know, what? Okay. Do I have? Yes, I do. So I push a boat. Okay. All right, what was the equation? Y equals 3x squared minus 2x. Y equals 3x squared minus 2x plus 1. Doesn't hurt to visualize this, right? I don't think. So there's a tangent line through this, right? Through here. And what do we know about it? Its slope is negative 8. We need a point on the line. How are we going to find the point on the line? Well, we're going to say, hey, you know the x-coordinate. And if you just push on that dot there, which I probably can't, it'll actually give me the y-coordinate, but hey, we have to do actual algebra here. So we can say, okay, what do we know? We know the slope of the line is, let's see if we can squeeze this in here. Okay, so m is equal to negative 8. the point on the line is f of -1, right? Because we got that function, and we know that we're going through the point -1 something, so what's f of -1? So f of -1 is equal to 3 -1 squared minus 2 times -1 plus 1. Didn't we already work this out? 6. Okay? Hey, we already worked that out. So we know that the point that we're going through is -1, 6. Right? Is that right? 3 plus 2. All right, so you got slope, you got point, you do slope point. So what do you like? I like this one. Right? There's other where you can use y minus y1 over x minus x1 equals m. What else? You could use y equals mx plus b, stick in the m and the x and the y, and calculate the b. Right? Doesn't. You have a lot of choices. So we're just going to go what? Y minus 6 is equal to -8 x plus 1. This is actually going to very quickly give me slope-intercept form, right? Which will then change into general form. So y -8x minus 8, -8x minus 2, slope-intercept, right? Not the form we were asked for. So general form, what? Easy change, right? 8x, got to be positive, plus 1, plus 2, equals 0. And that is the answer to... So if I were to go back to Desmos and just graph y equals -8x minus 2, right? Because that's easier to type in than this. Okay, sorry, I kind of squeezed it. Let me drag this down. Okay, can you see? Okay, what are you doing now? Let's go back here. What was it? Y equals -8x minus 2. Let's go here. Y equals -8x minus 2. All right, and there we go, through the point. -1, 6. Show me the point. So there's the tangent line, right? Let's drag this down a bit. That disappear. Right? So here was the curve. We wanted the slope of we wanted the equation of the tangent line that went through the point where x equals -1, when x was -1. I mean, you can tell when x is whatever over here, you've got a positive slope to the tangent line, right? So we've got negative slopes, and then we come down here, and then we've got positive slopes. So we needed to figure out the slope of the tangent line. How do we do that? We use Formula 1, right? F of x minus, the limit as x approaches a of f of x minus f of a over x minus a. Plug it in. We know that the a value is -1. We worked it out. We got the slope was -1. We then had to figure out, well, a point. Well, the only point we know on the line is the point that's also, it's the tangent point. It's the point of tangent c, right? So we plug -1 into the equation. Found out that it was at -1, 6. We got a slope, we got a point, point-slope form, slope y-intercept form, whatever, right? You get the equation. Where you go? Push. Use Formula 1 to determine the... Okay, wait, was there anything else with that one, or is that... No, okay. Use Formula 1 to determine the equation of the tangent line to f of x equals 3 over x plus 2 at x equals 4. What do we do? Same thing, right? So let's start with the formula. Oh, yeah, I think you got to get out paper. I don't think there's any room now, right? You can't squeeze. Okay, you cannot squeeze calculus, right? Well, although there is a theorem called the squeeze theorem. We talked about it. I think that was discussed in finding the limit of the sign thing. Right. I think we waved hands and said, look, squeeze theorem. You know, if you go on into calculus, you'll actually probably prove the squeeze theorem, just like you'll do the epsilon delta definition of limits and stuff. So you'll actually look into the squeeze. Squeeze theorem just said, I'm looking for this thing which I know is between these two things, and if they come closer together, well, then that thing has to be, you know, that's all. All right, so M is the limit as x approaches a of f of x minus f of a over x minus a is equal to, do not drop the limit, right? This is my fear. You guys are going to be dropping limits and thing, right? And it's just, you write expressions, and then I have to take marks off. And discuss with how many marks do we take off? Is it each time, or is it just once? Okay, so limit as x approaches 4. F of x minus f of 4 over x minus 4. Okay, we fill in. You're going to use lots of paper. As a teacher here used to say, drop math 31 and save a tree. Right? Because you're going to be using a lot of paper. That's okay. All right, what's f of x? 3 over x plus 2, let's keep that in brackets, minus 3 over 4 plus 2 over, all right, so we're just substituting in, right? F of x is defined, there it is on the board, just copy it down, 3 over x plus 2. F of 4, okay, put in a 4 for x. Oh, fractions. Okay, remove the brackets. That's 3 over 6, right? Which is a half. Over, not done. Common denominator. All right, so it's going to be right. What do we get? How much detail do you want? Not much. So I could just write like 6 minus, like that. Good enough? Yeah. Okay. Remember, you have to say no before they say yes. Here's the deal. You know this is going to become x minus 4. They're going to cancel. So, you know, like the secret, you've done enough of these that you kind of, hey, where's this going? We got to get rid of this x minus 4 in the denominator, otherwise it's a 0, so how do we do it? Well, guess what? That's going to come out to x minus 4. Okay, so x minus 4, 2, x plus 2, x minus 4. Don't forget there's a 1 up top, right? I mean, it's easy to cross stuff off and then just forget. Like, what do you put up there? Leave it blank? Don't leave it blank. Okay, so we can stick something in there, which is 6. What do we got? 1. What? What did I mess up?
Why isn't x negative x?
Oh. No. It was x equals 4, right? The limit as x approaches 4. Wasn't it?
Yeah, but like when you do 6 minus x plus 2, shouldn't x be negative, so it'd be like 0, right?
So this is negative x. Oh, you're right. Hang on. Okay, hang on. So what is that? That's going to be negative. Ah, wait. Okay, negative x plus 4. Okay, cross that off. That's a negative 1. There we go. Thank you. That's why you're here. So I'm not here to teach you. You're here to just fix my mistakes. I'm here to learn this. You're here to fix my mistakes while I'm here. And you might learn something in the process. Like how to fix my mistakes. Which will then fix your mistakes, and then we're all happy, right? Hey, my mistakes are all fixed. Yeah, my bad. Okay. So, do we have the correct slope now? Yep. Good. Because we can graph this and look at it and sort of see if it looks, you know, and that's the thing, you know, yeah, you can't use a graphing calculator. And if I was doing this at home, I wouldn't use a graphing calculator because they're horrible to look at, right? So, but you can use plot it in decimals and go in and graph that, say, yeah, okay, I got the right point. That slope looks like, well, first of all, the slope is negative, right? It goes down to the right, and it's not very steep, so 1/12 excuse me, seems reasonable. Plus, if I get this equation right, then that line should be a tangent line to it. So we'll do that after, right? Let's finish this off. Okay, what do we know? Let's go up here. So we know that m is equal to negative 1/12. F of 4 is equal to 1/2, right? So we worked that out. Okay, so that means that leads to what? We've got the point 4, 1/2, right? Okay, what do you want to use? Should we use y equals mx plus b this time, just for the heck of it? Some people like that. You know, I mean, it's whatever you like, right? I mean, there's no, it's 6 of one, half dozen of the other. So 1/2 is equal to negative 1/12 x plus b. Actually don't like that. I like the y minus y1 one, but yeah, I don't know. Any huge difference? Oh wait, hang on. So x is 4, right? Let's write that as 4. So 1/2 is negative what? 1/3. What's a half minus a third? A sixth.
Would it be plus because it's
What's a half plus a third?
5/6?
5/6. Good. You're keeping up your end of the bargain. This is good. It's as if I was doing this on purpose. That would be. So eraser. Did I ever mention? Really good eraser. Handy tool to have. Okay, for sure. Pencil. You cannot do this in pen, right? Like, don't even think about doing this in pen. All right. So what do we got? We got y is equal to negative 1/12 plus 5/6. One piece at a time. All right, so what do we got? 12, oh wait, that'd be an x, right? Negative 1/12 x. So 12 is equal to negative x plus 10, 12y. So we're going to multiply through by 12, remove the whatever, denominator. X plus 12y minus 10 equals 0. That seem reasonable? Should I graph this? Do you want to see it?
What if
No?
you just did like 1/12 x plus y? Would that work as well?
I think they asked for lines in general form, so. To determine the equation. It doesn't actually, in this one, doesn't actually say what form, right? So, you know, we would need to be more specific on a test, but just get used to putting it in general form. I would actually do both. Do slope intercept in general. Do you want to see it? Yes, no? Yeah? Okay. Yeah, I mean, let's look at it. So I'm going to need this and then the original, right? So when I switch over to decimals, just give me the, actually, let's do this here. Okay, so what was the original? So 3 over x plus 2?
Yeah.
Whoops. Whoops. So there's 3 over x plus 2. Is that a plus? Yes, eh? Does that look like a... All right, so there's 3 over x plus 2, and then what was the other one? Negative 1/12. Is that 3 over x plus 2? I swear I'm typing a shift. There we go. Now it looks like a plus. Okay, what was the other one? It was like negative 1/12 x? Plus 5/6 or something?
Yes, plus 1 is like my top instead. I think I was like, no, can you just put
And we were at the point where that kind of looks like a tangent point. So at the point 4, looks, it's projector mode, so the lines are thicker, and we can actually see that that's a plus. That was weird. And there we go. Woohoo, right? So that's stuff you can do at home, right? You can just go into Desmos, graph it. Do I have that? Yeah, it looks like it. That looked like a slope of -112, so I could count it out, but yeah, that seems reasonable, that, 12 and whatever. Okay. What's next? Use formula 2, which is actually kind of the better formula, to determine the line tangent to y equals 3 root x plus 1 at x equals 8. So what do we need to find first? The slope. How do we find the slope? Well, we're going to use formula 2. What's formula 2? All right, so I wrote that down here.
Can you just change that y to f of x?
Yeah, sure. They're the same thing, right? Yeah, you see a y, you can put f of x. You see an f of x, you can put a y. Depends if you like Leibniz notation or Newton's notation. Okay, so we want to fill this in, right? What are we going to write? Limit as h approaches 0. F of a plus h. Do we know this a? Yeah, a is 8, right? So let's write this. Okay, so let's do this before we fill in. Right, I want to show just one more line of detail. It's our first time using formula 2. Limit. Okay, you any good at function notation? Well, if you made it this far, you are, right? You got to be half decent at function notation. So what do we do? Everywhere we see x, we're going to put in 8 plus h, right? So it's going to be 3 times the root of 8 plus h plus 1. And I'm going to bracket it, and I'm going to bracket the 8 plus h, because I just love parentheses. And I'm going to bracket this, because I have to work it out, right? So this is 3 over h. Okay, I'll let that sink in. Okay, are we all synced?
Yep.
So it depends on which sink you're using. It's either synced or sunk. I don't really need that M still, but I'm carrying it for some reason. All right, what do we get underneath these? Square root of 9 plus h, h plus 9. I don't know. I feel like h. Well, yeah, square root of 9 plus h. I don't even have, you can't do that. Minus what? 9. Over 8. Yeah, you can't do that. Sorry. I wouldn't even be able to hit it as the board's off by. All right, how do we do this?
Same shit, but a plus sign.
And where does the same stuff go? So we rationalize So we rationalize the numerator, hoping against hope that we'll just end up with an h up there that'll go away. Then we can do this. Well, it's probably not against hope, it is going to happen. Okay, so let's do that. I don't know why I'm still writing m equals, although it is, but. All right, what do we got? How do I want to write it? I'm going to go 9 times 9 plus h. Let's start out like that.
So you just end up with an H on top of it. Oh no, you don't. 9H. Or am I just talking on my ass
I don't know.
here?
Let's do this. Okay, what do we get up top? 81 plus 9h minus 81, which is just 9h. And as h approaches 0 of 9h over h, what's going to happen to the h's? Well, we knew that, right? Denominators have this funny way of disappearing. It's not funny at all, it's just set up to do that. Okay, now we can put h as 0 in, right? Now you can drop the limit as h approaches 0 and just write, I don't know why I'm carrying this m down, but I am. Okay, what do we get? 9. So that's square root 9, which is 3, times 3, which is 9, plus 9, which is 18, 9 over 18. I'm thinking a half. Okay. Feel free to show more work if it helps you, right? Like you actually just want to put in the zeros, you know, whatever you need to show. Just, I think you should end up with a half. Okay, we're good? It's a half. Is that it? We're done? No. We just found the slope. It's not the good old days, eh? I had 2 points. I just did this minus this, and there was the slope. We're going to do all this. M equals 9, and what do we want? F at 8?
M is 1/2. Where does that 9 come from?
That's a good question. It was right there. It was a 9. I just wanted to copy it down. What was f of 8? 9, right? 8 plus 1 is 9. Root 9 is 3. 3 times 3 is 9. Okay, so f of 8 is 9. So we have the point. Got the slope, got the point. Use your favorite method and determine the equation of the line. I don't know if this one's any better. Y minus 9. I think I like this better. And that's what I get. You get? Should we graph it? No, I think you got to move the 2y over. Because your x needs to be positive, right? So first step is, okay, got to get rid of fractions. Should be 10 though, shouldn't it? Yeah. Just checking. Okay, so I'm going to multiply through by 2 everything, right, including the 5, which you should have caught. I made that error just so you would catch it. So 2y equals x plus 5, or sorry, so 2y equals x plus 10. X is positive, move the y over, x minus 2y plus 10 equals 0. I think you can actually graph that in Desmos as well. You can punch in x minus 2y plus 10. I will forego graphing this, I'm sure it works. Is there more? I think there's like one more. there more? There is no more. 4. Y equals negative 2x squared plus 3x minus 5. That's a parabola. It opens down. It's got a vertex somewhere. I don't know where, and I'm not completing the square to figure it out. Determine a simplified expression for the slope of the tangent at x equals a. Ha! So if we get a general expression, then we can use that to determine the slope at x equals 5 and the slope at x equals negative 2, right? We no longer have to, so we can say, what's the tangent at any point? Well, I'll get you a general formula in terms of a. You plug in a value of a, you'll get the slope. Okay, so how are we going to do that? Well, we got a formula, we should use the formula. So a. So this formula is going to come out in terms of x and a, right? Okay, I'm not going to write m equals all the time. So limit f of x, that's here. Minus f of a in general. Okay, do the math. So remove the brackets. Now what? Now we got like part B, right?
Yeah.
Okay, so in part, yeah?
For the x and the a, could you put like a 3 in front and then be x minus a?
So like simplify this a bit.
Between the x and the a, could you find a common factor of 3 and then you have 3 bracket x minus a?
All right, so let's see what we got here. So let's take, so we got that. Oh, good idea. Where do you want to go from there? Keep going. This looks like a difference of squares, right? Okay. Good. I'll stop too soon. So what do we do with the x minus a? Got it, right? Common factor. Okay, so what do we got? Ooh, this will be nicer. Nice, simple expression. Coincidence? I think not. Okay, good catch. So factor out, we factored out the top, right? We factored a 2 out and a 3 out. And so there's the difference of squares. We get the x minus a's, and they're all going to cancel. Because ultimately we know that has to happen anyways, right? Because that bottom term, which is going to go to 0, it's got to cancel out. So let's do that generally before we start. Okay, so we want what? Specifically in part B, we want the x equals 5. So let's extend that, I guess. Oh, well, I guess x is approaching 5. That's just a 5, right? Put the x back in there. Now we put the 5 in, correct? Negative 17. Okay, and what was the other one? X equals negative 2. Negatives there, what's that, 8, 11? Seems good. Could always graph it. Expect to see some pretty steep lines. And what was left? Determine the value of, really? Determine the value of a, so the tangent to y equals negative 2x squared plus 3x minus 5 at a is parallel to 3x plus y equals 6. Okay, got to go to a new page for that. I've already extended this. Can't go to a new page. Okay, C. Okay, so what was it? Parallel to 3x plus y equals 6. So let's put it into slope-intercept form. We find the slope of the line that we want to be parallel to is negative 3, right? So what's the slope parallel? Symbol for parallel. So the parallel slope is negative 3, also negative 3, right? So perpendicular would be positive 1/3. Okay, so they could ask that, find the slope perpendicular, blah, blah. All right, so what do we have? And what did we come up with? Go back. So our expression for slope was limit as x approaches a negative 2x plus a plus 3. Okay, is that it? Short-term memory is bad. I don't know. I just looked at it. Okay, so that means we want so the limit as x approaches a, x is going to be a, and we want to figure out the value of a. We've got to solve this. We want the slope to be negative 3, so that they're parallel. They write 6 there. To make negative 4a plus 3 minus 6. Three halves?
Yeah.
Huzzah. Done. I have no idea where the done thing is. How do I stop this? I think it's there.